Hi everyone, this is my Module 2 video for Infiltration. To start us off, I use the NGSS standard 3 to 5 engineering design. I think because we're given a problem and we have to be the ones to develop a solution, that's why I centered around the engineering design process. We were asking questions, we had to carry out the investigations, we were the ones that were constructing the explanations and design solutions. We had to engineer through the problems, develop possible solutions, optimize the design solution, then ultimately, like, the whole idea of the inquiry was the engineering process to help the world in general. So as far as the inquiry went, for the ask, our question was how can we reduce runoff when we build and how can we promote infiltration when building? The imagine was I said a possible solution is to use rock or pea gravel. That was just representing different layers of rock that we could put underneath our building to like gather some of the various sediments and everything like that. So my plan was I used an orange juice bottle, pea gravel, mulch, soil, a watering can, water, and then a vase for the collection. To create it, at the bottom of the juice bottle, I used a layer of pea gravel, and then I put mulch in the middle, and then I put the soil on top. So I put the soil on top because that's where we would actually put our plants into. And then I used mulch as just a layer to represent, like, if we put sticks or something a little thicker underneath the soil, and then the pea gravel at the bottom. I'll show you later on in the video, but this didn't work so well. So an improvement idea to actually put plants in there and use the roots to prevent the runoff, to add sand and crushed gravel to the layers as well. So like a potential order would be from top to bottom, the plants and the roots on top, then the soil, the mulch, sand, crushed gravel, and then pea gravel at the bottom. I'm using that to kind of show like the different layers of the Earth's crust and just using smaller scale items for our inquiry. If you look here, this is my actual idea. So I put the pea gravel at the bottom, and then I put the mulch to represent those layers of like sticks and just larger items with the soil on top. The soil area, this is where I would actually put the plants, and then I put the different layers of other sediment and the fine gravel and then the actual gravel, and hope that the different types of gravel and different types of rocks stop the sediment. I mean, you can see in here that some of the sediment did get stopped in between the rocks. That was my overall idea. Then this is just my test. So filling the water and then collecting in the vase. As you can see here, it's not very clean, but overall, the sediment from the mulch and the soil did not get in there. It's just dirty water. You don't really see things floating around in it. And I stirred it up to see if I could find anything, and it was, I mean, water that pretty much looks like chocolate milk. So yeah, I wouldn't drink it, but as far as eliminating the actual sediment in it, that did work. So then if you compare this to the STEM practices, I said for science, it's just planning and carrying out investigations. So we're the ones who had to plan it and then actually test it to see if it worked or not. I also said that with engineering, because with the plan, with the science knowledge, we had to actually develop a solution and build and test the solution. I said defining problems because our problem was defined that we had to our problem would be like our building practices increase runoff, which leads to the water not being clean. We wanted to promote better infiltration. And then as far as the solutions go, we needed to actually build a model and test it. And then we had to take our results and analyze, did they work or not, and then make possible adjustments or improvements.